Welcome back to Bow and Sight's Pulse. Teaching a robot hand to gently hold a fragile egg is a classic engineering challenge. But did you know that the exact same mathematical balance is required to keep modern AI agents from going completely off the rails?
Today, we're diving into why agent loop engineering is really just control theory, but with a new vocabulary. I spent years studying control theory, negative feedback, PID controllers, stability margins. When I started building AI agents, the terms were different. Agent loops, iteration budgets, tool use cycles. It sounded like new territory. Then after 3 months of daily use, I realized loop engineering is just closed loop control theory.
The math is different, but the architecture is identical. In control theory, you measure the output, compare against a set point, compute the error, and adjust input. The agent cycle is identical. Observe, decide, act, verify. The user's goal is the set point. Tool outputs are the sensor. The next action is the control signal. The loop closes exactly the same way. A PID controller uses proportional, integral, and derivative signals. In agent loops, P is how aggressively the agent changes its plan when progress stalls. I is context accumulation, remembering past tool outputs and session history. D is the agent's behavior near completion, narrowing search and verifying more carefully. The mapping is direct, just with different names. Every control engineer knows unbounded loops oscillate or diverge. Agents face the same risk, infinite loops, token exhaustion. The solution is a hard iteration budget, just like a stability margin. In Hermes Agent, 90 turns is the default, enough to complete most tasks but bounded to prevent runaway behavior. This is gain margin in agent clothing. Adaptive controllers adjust their own parameters in real time. GEPA, the outer loop in Hermes Agent, reads execution traces, identifies struggles, and proposes prompt improvements. It runs these against a test suite, then surfaces candidates for human review. This is model reference adaptive control. The inner loop stabilizes the task, the outer loop tunes the inner loop's gains, and the human gate ensures changes don't destabilize the system. The real challenge isn't understanding the loop, it's instrumenting the feedback. A controller is only as good as its sensor. For agents, that means designing clear completion criteria, capturing rich execution traces, and building test suites that catch regressions. This is the same problem control engineers have always faced. The quality of your control is limited by the quality of your measurement. If you studied control engineering, you already understand the core principles of building reliable AI agents. Stability margins, integral windup, completion criteria, timescale separation, they all map directly. The vocabulary changed, but the architecture endured. You know more than you think. Loop engineering is just control theory wearing a new name. That's the pulse for today. Whether you're navigating AI, leading a team, or investing in the next big tech trend, I hope this quick breakdown brought you some value. If it did, hit that subscribe button down below. It helps the channel grow and ensures you won't miss the next update. For deeper dives, check out the main Bow Insights channel. Thanks for tuning in, keep building, and I'll see you in the next one.